In the beginning, Excel and other spreadsheets were used for accounting, but also for managing lists of items such as product inventories, assets, contacts, employees, essentially small databases. Today, it is almost common sense that you could do that in Excel, but for real-life applications, you definitely should use other tools that are better suited for these kind of tasks. Apart from these backward-oriented applications, which deal with storing data and processing information, Excel is also used for forward-looking tasks like planning, budgeting, financial modeling. The weaknesses and flaws of spreadsheets for modeling are basically the same as for data storage and analysis. For modeling, you can check them out here at beyondexcelmodeling.com, for example. That's why many see the solution for replacing Excel for planning and modeling in the use of BI tools like Business Objects, Oracle BI, Hyperion, IBM Cognos, etc. Sounds logical at first glance, but there is a fundamental flaw. BI tools and databases are great for dealing with tons of data. Today's world is full of data, and we are producing even more of it every day, exponentially more. That's why big data is such a hype. And it's necessary and useful to cope with the sea of data and make sense of it, no doubt. With BI tools, you basically categorize, sort, compare, analyze, find out patterns, structure, etc. All this based on data. To do this, you need data. The problem is, though, that data is only available for the past. Data is traces of things that have already happened. For the future, and with planning and financial modeling, we only deal with the future. There is no data. The data of the past was generated by some kind of mechanism, whether we know and understand it or not. We could call this mechanism the business logic, which is all the many things that happen and influence each other when you run a business. Customers decide to buy your product. You order supplies and materials. Customers pay 30 days after they got the invoice. You take out a loan, pay monthly interest, and repay it at the end. The value of your assets is decreasing, so you write them off. You spend money on advertising in hope of more customers to buy your products, and many more things. For accounting, it's enough to record the monetary traces of the business: revenues, expenses, assets, liabilities, cash flows. You don't need to know what actually happened before a customer bought your product. You don't need to know what were the rationales behind the supplies orders, its size and timing. As long as you recognize the revenues and expenses correctly, everything is fine. Financial modeling is not about data, it's about logic. When you need to come up with revenues and expenses for the future, however, you must know the logic of your business. Capturing this logic is the primary task of financial modeling. Not adding numbers, but building a model of the business logic that reflects what's behind the numbers, or actually before. To capture information about the logic, BI tools and databases are not well suited. They are good at storing atomic pieces of information, but not relationships, influences, formulas. That's why Excel is used. Not because you can handle numbers, but because you can use formulas to describe how numbers are generated. So if we want to replace Excel for building financial models, it's not very clever to aim for BI-like tools, is it? it's not always the hammer you need. Rather than storing and manipulating data, we want to store and manipulate the business logic. So rather than a database, we need kind of a logic base, a tool that allows us to keep track of the dependencies and influences of a model, that allows us to write formulas in a compact, human-readable, understandable way. Formulas that can handle multidimensional data with ease, so you can build the most complex models that cope with the complexity of reality you want to model. Sure, the term logic base is a terrible word, and I'm going to drop it immediately and will never use it again. I just wanted to highlight that we don't need something like a database, which is a better replacement for Excel for backward-looking, data-related tasks, to replace Excel for forward-looking jobs like financial modeling and planning. But how should the software look like that is capable of storing business logic? Well, to me, there are three essential aspects. First, define variables as a function of others. A killer feature of Excel and other spreadsheets is that you can define the value of a cell by putting in a formula that tells the machine how to compute this value based on other values. This is important to trace back the things that influence an individual value. You can always tell, sometimes easier, sometimes harder, why this value is like it is. A database, in contrast, doesn't store a formula, but the actual number. That number might be produced by a formula or an algorithm somewhere in the application, for example, when yearly numbers are broken down to quarterly or monthly figures. But looking at the monthly values won't tell you why they have this awkward seasonal pattern. So the software should allow for defining a variable by a formula. Even better, if the formulation language is clear and intuitive and uses variable names so that the business logic is captured in an understandable form. In this example here, the variable passengers is defined by a formula that tells that it's calculated by landings times passengers per landing. This captures the business logic. It is easy to read and understand. It allows you to detect where the numbers come from, and it ensures that the numbers are always calculated using these inputs and updated when inputs change. So in comparison to a database where the record is the building block, defined by properties and values, the variable is the smallest element in the model, mainly defined by its formula, the logic. The second thing is to keep track of relationships and influences. Understanding a model logic from looking at each element and each formula individually is hard. A machine is capable of this, but the human brain usually works differently. Humans like to draw diagrams with boxes and arrows when they want to explain what is influenced by what and how things relate to each other. That's why influence diagrams were developed in the 1970s. Excel offers no way to visualize the overall structure of a model. Using cell references in a formula makes it laborious to find out which variables or rather cells depend on each other by tracing formulas from one cell to another. Of course, you can trace the input of a selected cell, for example, by color coding cell references to identify its inputs, or with the audit tool that displays arrows from the inputs or to the outputs of a selected cell. These tools, however, can show the dependencies of only one or a few cells at a time. Database and BI tools aren't better suited for this either. This is because relationships between the variables and its computational origin, the algorithm that might have calculated the value, are not physically connected, like in a formula. The various attempts in these tools to come up with charts, maps, diagrams to visualize the structure of a planning model are, by nature, just an afterthought and kind of artificially put on top of the actual model. Instead, a modeling software should treat the visual representation of the model as an integral part, ideally being the actual interface to interact with the model. Analytica is a software package that does exactly this. Models are organized as influence diagrams, variables and other objects appear as nodes of various shapes on the diagram connected by arrows that provide a visual representation of dependencies. These influence diagrams may be hierarchical. This is a single module node on a diagram represents an entire submodel, so that even very large real-life models can be built and navigated visually. The influence diagram, in this sense, might be the equivalent of the linked tables in a database. And the third thing is separate formulas from data. Business information is multidimensional by nature. Products are sold per time unit, by region, by distribution channel, etc. Database and BI tools are well suited for organizing multidimensional data of the past. When building financial models of the future, at least some of this multidimensionality is required too. In Excel, however, dealing with multidimensional data is hard, laborious, and error-prone. You are forced to work at the level of cells rather than tables, because Excel formulas usually refer to individual cells and not to tables. Each cell must contain a separate formula, even when all the cells in the table have identical relationships with the cells of other tables. Of course, Excel offers a relatively convenient way to create such tables by stretching one cell across the table, provided you use correct absolute or relative cell references in the initial formula. But after you have created a table, the fact that all the formulas are essentially the same gets lost. Indeed, if someone changes a single formula in a table, by design or by accident, it's very difficult to detect, which is a common source of mistakes. So ideally, a modeling software should overcome these weaknesses of Excel and provide a way to write formulas without worrying about dimensionality of the ingredients. The same example from before shows that the variables landings and packs per landings, which are used in the definition, are no single numbers, but actually three-dimensional arrays indexed by model period, region, and flight type. To calculate the actual value of passengers, Analytica repeats the calculation over each dimension, but recognizes when the same dimension occurs in both values and treated as the same dimension during the calculation. This way, formulas are separated from the actual data. This allows that new dimensions can be introduced or removed from an existing model without requiring changes to the model structure or changes to variable definitions. Certainly, there are other features of financial modeling and planning software should offer, but these three are, in my opinion, the ones that are critical for dealing with forward-looking information, and the ones where BI tools are of no help. Nobody using Excel for financial modeling will honestly deny the fact that spreadsheets are only the second best solution for the task. They are flexible and apparently easy to use, okay, but this comes at a price. There are numerous studies and examples showing that Excel models are extremely error-prone, if not dangerous. In the video description, you find a list of good reads on the topic. Obviously, there is a need to replace Excel, but replacing it with tools that rely on the concept of data, also known as professional planning software, won't be a good replacement. A modeling tool must be able to deal with variables, influences, hierarchies, dimensions, and arrays. And it should ideally display these things in a human-friendly, visual way, so the modeler can interact with them directly and intuitively. BI tools are a hammer where a screwdriver is needed.